Astronomers at the Atlas Observatory in Chile, scanning the night sky for potential threats, first detected a peculiar anomaly in July 2025. Initially classified as a routine interstellar object, 3I Atlas revealed itself as the third confirmed visitor from beyond our solar system, following in the footsteps of Oumuamua and 2I Borisov. Its hyperbolic trajectory, unbound by the sun's gravity, suggested origins in a distant stellar system, perhaps ejected by gravitational perturbations billions of years ago. Early spectra indicated a composition rich in ices and volatiles, with unexpected non-gravitational accelerations hinting at outgassing or sublimation processes. As telescopes worldwide trained on this wanderer, its faint coma expanded, releasing dust and gases that painted a ethereal tale against the void. Yet subtle discrepancies in its motion, slight deviations not fully explained by solar heating, began to emerge from the data. Scientists pondered whether these were mere artifacts of observation or signs of deeper anomalies. The object's velocity, exceeding 245,000 kilometers per hour, placed it on a path grazing Mars before slinging toward the sun, offering a rare window into extrasolar materials. As international teams collaborated, piecing together orbital models and chemical fingerprints, the true scale of the mystery started to unfold, challenging established paradigms of cometary behavior. But could this solitary traveler conceal a companion, hidden in the glare of its own emissions? Delving deeper into 3I Atlas's path, researchers uncovered irregularities that defied conventional explanations. Hubble and ground-based observatories captured high-resolution images, revealing a nucleus estimated at several hundred meters across, shrouded in a dynamic coma of sublimating ices. Spectroscopic analysis detected unusual compounds, including traces of refined nickel alloys, materials not typically formed in natural cosmic environments, sparking debates over potential contamination or exotic formation processes. The comet's acceleration, beyond what gravity and solar radiation pressure could account for, suggested asymmetric outgassing, yet models failed to fully align with observations. Data from ESA's ExoMars orbiter, as it passed nearby in October 2025, provided close-up views of the object's surface, hinting at fractured terrain and possible internal activity. Astrophysicists hypothesized that 3I Atlas might originate from a disrupted planetary system, carrying remnants of ancient collisions. However, radar echoes from Arecibo's successor telescopes indicated density variations inconsistent with a uniform icy body, raising questions about hidden structures within. As computational simulations recreated its interstellar journey, tracing back to potential source stars, the enigma deepened with reports of faint radio emissions, though unconfirmed. These findings positioned 3I Atlas as a bridge to understanding distant worlds, yet the persistent deviations in its orbit whispered of external influences. What if an unseen force was guiding its course, lurking just beyond detection? In the midst of scrutinizing 3I Atlas, astronomers stumbled upon faint gravitational perturbations rippling through its trajectory. Advanced algorithms processing data from the James Webb Space Telescope isolated a secondary signature, a massive object shadowing the comet at a distance of mere astronomical units. Dubbed provisionally as the Atlas Companion, this enigma registered no visible light initially, evading optical surveys until infrared imaging pierced the veil. Estimates placed its diameter at over 10 kilometers, dwarfing 3I Atlas by a factor of 100 in volume, with a mass potentially exceeding 33 billion tons. The discovery, announced in late September 2025, sent shockwaves through the scientific community, as no prior models predicted such a binary interstellar pairing. Orbital reconstructions suggested the duo entered our system in tandem, perhaps bound by weak gravitational ties or shared origins. Spectral hints revealed a dark, non-reflective surface, absorbing most incident light, which explained its elusive nature. Teams at NASA and ESA mobilized additional assets, including repurposed probes to gather more data, while theorists grappled with the implications of such a colossal wanderer. The object's proximity to 3I Atlas raised alarms about potential interactions, such as tidal forces or material exchanges, observed in subtle dust streams bridging the pair. Yet, how could such a massive entity remain concealed until now, and what binds it to its smaller counterpart? Confronting the disparity in size, scientists juxtaposed the diminutive 3I Atlas against its gargantuan neighbor, revealing a cosmic oddity without precedent. The smaller object's nucleus, roughly the size of a city block, paled beside the companion's Manhattan-scale bulk, implying vastly different formation histories. Volume calculations underscored the 100-fold difference, with the larger body's density suggesting a rocky metallic core, possibly enriched with heavy elements from a supernova remnant. Comparative spectroscopy highlighted contrasts. While 3I Atlas outgassed volatiles like water and carbon dioxide, the giant emitted sparse anomalous particles, including metallic compounds akin to aerospace alloys. Trajectory analyses indicated the pair's synchronized entry into the solar system, with the larger object exerting subtle gravitational influence on the comet's path, accounting for earlier anomalies. Simulations explored scenarios of a captured binary system, where the giant ensnared 3I Atlas eons ago, or a fragmented progenitor body splitting during interstellar travel. Observational campaigns, blending radio astronomy and LiDAR, mapped surface features on the behemoth, uncovering cratered expanses and possible fissures. This comparison not only amplified the mystery, but also illuminated potential insights into extrasolar planet formation, as the duo carried chemical signatures from alien stars. But if their bond is natural, why do emissions from the giant mimic engineered materials? As evidence mounted, hypotheses proliferated to explain the enigmatic pairing. Mainstream theories posited a natural binary interstellar object, perhaps a rogue planetoid with a captured moon-like companion, ejected from a chaotic stellar nursery. Gravitational dynamics supported this, with the giant's mass stabilizing the duo's journey through the galactic void. Alternative models suggested fragmentation from a larger body, shattered by close stellar encounters, leaving 3I Atlas as a volatile, rich shard. Yet, the detection of refined alloys in emissions challenged these views, prompting fringe speculations of artificial origins. Could the giant be a derelict probe from an extraterrestrial civilization, with 3I Atlas as a decoy or exhaust plume? Harvard astronomers, drawing parallels to Oumuamua debates, analyzed the data for non-natural signatures, such as geometric shapes or modulated signals, though none were conclusively found. Chemical assays via remote sensing hinted at isotopic ratios alien to our solar system, fueling discussions on panspermia or interstellar pollution. International panels convened virtually, debating the probabilities, while supercomputer models tested each scenario against observed behaviors. The suspense built as each theory unraveled under scrutiny, leaving room for paradigm-shifting revelations. What if the truth lies in a hybrid explanation, blending nature's chaos with intelligent design? Pushing technological limits, astronomers deployed an arsenal of instruments to pierce the veil surrounding the duo. The James Webb and Hubble telescopes captured multi-wavelength data, revealing thermal gradients on the giant's surface suggestive of internal heat sources, perhaps radioactive decay or residual geothermal activity. Ground-based interferometry arrays synthesized images with unprecedented resolution, spotting tendril-like extensions from 3I Atlas toward its companion, interpreted as material transfers or plasma interactions. Challenges abounded. The object's high velocity and solar proximity caused glare and distortion, necessitating adaptive optics and AI-enhanced processing. Data from repurposed missions like Voyager relics or new CubeSat swarms provided complementary angles, detecting faint magnetic fields enveloping the pair. Analysis uncovered pulsed emissions in the radio spectrum, initially dismissed as noise, but later correlated with the giant's rotation. Collaborative efforts across continents integrated these findings, constructing 3D models that simulated future behaviors, including potential close approaches to inner planets. Yet, gaps persisted, with key questions about composition requiring in situ sampling, a feat beyond current capabilities. But as the objects draw nearer to the Sun, will escalating activity expose their core secrets or unleash unforeseen dangers? The presence of this colossal intruder and its companion posed profound implications for our cosmic neighborhood. Orbital projections indicated a slingshot around the Sun, potentially altering trajectories of near-Earth asteroids through gravitational nudges, heightening planetary defense concerns. Scientists modeled scenarios where debris from the duo could seed meteor showers or contaminate atmospheres, carrying exotic microbes or chemicals. The giant's mass, rivaling small moons, raised alarms about tidal effects on gas giants during flybys, though distant. Broader insights emerged. Studying their compositions could unlock clues to galactic chemical evolution, informing exoplanet habitability models. International agencies monitored for collision risks, recalibrating alert systems inspired by Atlas's detection prowess. The event underscored humanity's vulnerability to interstellar incursions, prompting calls for enhanced surveillance networks. As the objects accelerated inward, their interactions intensified, with observed brightening suggesting increased outgassing. This real-time laboratory tested theories of solar system stability, revealing how external visitors might have shaped Earth's history through past impacts. Yet, if their path veers unexpectedly, what cataclysmic consequences await our world? In the culmination of this celestial saga, the unanswered questions surrounding 3I Atlas and its massive shadow loomed larger than ever. Despite exhaustive analyses, the origin of their bond remained elusive. Were they forged in the same stellar crucible or drawn together by chance in the interstellar depths? The artificial-like emissions defied resolution, blurring lines between natural phenomena and potential artifacts of distant intelligences. Future missions, conceptualized in haste, aim to intercept similar visitors. But for now, the duo slipped toward egress, carrying secrets into the void. This encounter challenged fundamental assumptions about isolation in the universe, suggesting interstellar traffic might be more common than imagined. As data archives grew, new generations of researchers would revisit the enigma, armed with evolving technologies. The event served as a stark reminder of the cosmos's vast unknowns, where each discovery peels back layers only to reveal deeper mysteries. What other colossal shadows traverse the darkness, waiting to intersect our fragile domain?